The topic to be said today is trigonometry. Why this topic said trigonometry? At once I can't go into. It'll take some time for me to get to the subject. In trigonometry, the first thing we talk of is angle. You might have heard from O-level mathematics, but still, we have to talk in detail. Look here. Consider a situation where two lines intersect. When two lines intersect, the space in between is called an angle. When two lines intersect, the space in between is called an angle. This could be said an angle, this could be said an angle, this could be said an angle, this could be said an angle. From O-level geometry, you know this angle and this angle are equal. Then we come to talk of measurements. Measurements of an angle. Measurements of an angle. One way the angles could be measured are degrees. From O-level knowledge, you have this knowledge where angles are measured in degrees. Now we got to talk in detail in advanced level mathematics. And then again we take another units called, we call it radians. It's new to you and I'll explain what it is. Degrees and radians. Then 1 degrees. Degrees. Now, when to talk of a degree, the angle around a point divided by 360. The angle around a point. Angle around a point divided by 360. You take it to be 1 degree. To denote degree, you put a small not like symbol here. 1 degree. Then you may ask me how and why you divided by 360. That is the question you should have to ask your O-level teacher when you are being taught this when in small classes. Divided by 360, that is the initiation of mathematics in the world. And the start, those mathematicians have taken this to be 360. And we got to go the same manner. The start of mathematics may go up to some 6,000 years. You may ask me how. If I try to talk the history of mathematics, I'll not be able to teach you the subject within this small time. I've got to talk to you. Angle around a point divided by 360 is 1 degree. Then 2 radians. radians. You take a circle. You take a circle. The radius of the circle. If you take an arc, where the length of the arc, is equal to the radius, a certain angle we get, we call it 1 radian. Arc, the length of the arc is equal to the radius. Then this certain angle is said to be 1 radian. Now basically, if you take like this, say this certain distance is d and radius r, the angle theta is equal to, we'll take it to be L. Radian theta is equal to L over R. R over R is 1 radian. Then basically the angle comes to L over R. How many of these values here in this angle? L over R. And the angle around a point divided by 360 is 1 degree. Then for a circle, how many degrees? The angle around the point divided by 360 is 1 degree. Then the angle around the point comes to 360 degrees. When talking in radians, the angle around a point is taken to be 2 pi. This was divided by 360. Why you took it like that? You take it like that, you got to remember. The angle around a point from radians, taken from radians, you call it 2 pi. This pi is familiar to you. Can you remember when O-level mathematics concerned? We said values like 2 pi r square, the area of a triangle, the perimeter of a circle. Then, if the complete length of this is L, if this complete length of this L over R is the angle. L over R is the angle. When the angle comes 2 pi, L over R, if this angle becomes 2 pi, the complete angle, then you get L is equal to 2 pi R. O-level mathematics, you took this as a periference or as the complete distance around a circle. Parameters, you call it the parameter, periference, 2 pi R. Then, in trigonometry, basically we take 2 axes one vertical and one horizontal. One vertical and one horizontal. You take a line segment OP. You take a line segment OP of length plus R. You take a line segment of length plus R. Now you may ask me why the reason you take it plus R. We take it like that in mathematics. You take it as such, Magana. Then, when now this line segment OP can turn this way, there is anti-clockwise, or is this line segment OP can turn this way, clockwise. Clockwise is the direction where the hands of a clock alters. The opposite direction, anti-clockwise. Now, in mathematics, when OP turns anti-clockwise, the angles created are defined as plus angles. When it turns clockwise, the angles created are defined minus angles. When it turns clockwise, the angles created are defined as plus angles, anti-clockwise plus angles, clockwise minus angles. You may ask me why? No, take it like that. When turning anti-clockwise, that's how the subject being created. When turning anti-clockwise, the angles plus angles. When turning clockwise is minus angles. Then the y-axis and the x-axis. Now the basics of trigonometry, OP, the line segment OP is of length plus R. From P we draw a perpendicular to the horizontal line, let it be M and let this angle be theta. Mark it. The initial definitions of trigonometry is that we define sine theta. This comes to O-level mathematics. Sine is what? Opposite divided by the hypotenuse. PM over OP. You know it by now. Opposite divided by the hypotenuse. Cos theta is adjacent divided by the hypotenuse. We take it like that. You took it like that in O levels. That's the basis of it. Then tan theta is equal to opposite divided by the adjacent. PM divided by OM. Tan theta PM divided by OM. Furthermore, you get sin theta divided by cos theta. This you didn't talk of when you are in the O-level class. Sin theta divided by cos theta. Sin theta is PM over OP. cos theta is OM divided by OP. Sin theta PM over OP, cos theta OM over OP. The lower part of the numerator and the lower part of the denominator gets cut. You get PM over OM, and PM over OM, PM over OM is tan theta. Now you got to keep this in memory, got to memorize it. Sin theta divided by cos theta is tan theta. Then secondarily, these initial definitions, these three was done for O levels, this was not. And then secondarily, we defined 1 over sin theta, we call it cosec theta. 1 over cos theta, we take it to be sec theta. 1 over tan theta, we take it to be cot theta. 1 over sin, now you got to memorize these values. As such, you are memorizing formulae 7 into 4, 7 into 3 is 21, 7 into 4, 28. You studied in small classes. As such, you got to study this. Why 1 over sin theta is cosec theta. 1 over cos theta, sec theta. 1 over tan theta, cot theta. When trying to memorize this, 1 over sin theta cosec theta, 1 over cos theta sec theta, 1 over tan theta cot theta. When it became 1 over tan theta cot theta, this is different. You can remember easily, but you get confused. 1 over sin theta cosec theta or is 1 over sin theta sec theta. 1 over cos theta sec theta or is 1 over sin theta cosec theta. You just keep in your mind cosec. What you are going to keep in your mind is cosec. 1 over cos theta sec theta. Cosec. You keep it in memory. 1 over cos theta sec theta. When is 1 over cos theta sec theta, 1 over sin theta is cosec theta. Again, we take that line segment OP. You draw perpendicular from P to the x-axis and let the foot of the perpendicular be M, the angle theta. When you take it as such, applying the Pythagoras theorem to this rectangle triangle, you get OM square plus MP square is equal to OP square. OM square plus MP square is OP square. Then you divide the complete expression by this OP square. OP square divided by OP square is 1, or else OP square divided by OP square. Now I would write this as OM over OP. This I would write as OM over OP, complete thing square. So why? OM over OP is cos theta. In the intention of writing cos theta here, I wrote it in the form OM over OP. Again, this I would write as MP over OP, completing square, and this is 1, this is 1. Then OM over OP is cos theta, completing square. MP over OP, MP over OP is sin theta. For MP over OP, I would write sin theta. Completing square is equal to 1. Now, how can you read this? Cos theta completing square plus sin theta completing square is equal to 1. But still, for it to be easier for you to write, and when written, for it to be easier for you to talk, we write it in a form cos square theta means the same thing. Cos theta completing square. In short, I write cos square theta. Sin square theta is equal to 1. The most basic equation in trigonometry. Most basic and the most initial formula in trigonometry. Cos square theta plus sin square theta is equal to 1. Now you got to memorize it. You got to memorize it. Now, coming from O-level knowledge, more than O-level knowledge that I've spoken up to now is sin over cos is tan. Talk with me with the subject and with the subject. Sin theta divided by cos theta is tan. You remember the word cosec. Remember the word cosec. 1 over cosec, 1 over cosec, cosec. 1 over cosec, 1 over sin cosec, 1 over tan cot. Then you got to keep in mind cos square theta plus sin square theta is equal to 1. This is the most initial formula we learn in trigonometry. The first formula we learn in trigonometry. While you memorize this, look here. Cos square theta plus sin square theta is equal to 1. Then cos square theta is equal to the sin square, take to the other side. 1 minus sin square theta. This sin square theta is equal to, take this cos square to the other side. 1 minus cos square theta. Sin square theta is equal to 1 minus cos square theta. When you memorize this, you don't memorize this alone. You memorize all three values together. Cos square theta plus sin square theta is equal to 1. Cos square theta is equal to 1 minus sin square theta. Sin square theta is equal to 1 minus cos square theta. For it to be easier for you to talk about the subject, we say cos, whatever the angle here, when we wrote theta here, it comes in theta. Instead of theta, if I write something like A, this comes in A. Therefore, in short, cos square plus sin square is equal to 1. Cos square theta is equal to 1 minus sin square theta. And sin square theta is equal to 1 minus cos square theta. Now, little by little we'll go to handle some trigonometric questions at the start. And the first question I would take to handle with you would be, something like this. You got to prove that cos to power 4 theta minus sin to power 4 cos to power 4a minus sin to power 4a plus 1 is equal to 2 cos square a. Cos to power 4a minus sin to power 4a plus 1 is equal to 2 cos square a. Now these type of questions are called trigonometric identities. These type of questions are called trigonometric identities. You call it an identity when you mean to say cos a. For the angle theta, you took a complete thing to power 4. In short, we write cos to power 4a. Sin a, complete thing to power 4. You write sin to power 4a. Cos square a, cos a square. Now, this is the right hand side. This is the left hand side. Questions like these are called trigonometric identities. Now, in a trigonometric identity, you got to show that the left hand side is equal to the right hand side. In a question, you can start from the left hand side and go to the right hand side. Or else you can start from the right hand side and to go to the left hand side. Now, basically, what we do in questions is that we start from the longer expression and then simplify it to the smaller expression. We start from the longer expression, that is, we'll start from the left hand side. It is cos to power 4a minus sin to power 4a plus 1. Cos to power 4a minus sin to power 4a plus 1. We would say it cos square a square minus sin square a square. Now look here, 2 into 2 is 4. 2 into 2 is 4. This plus 1, we bring it here. And now you can remember of O-level mathematics. The difference of two squares, x square minus y square is what? Is x minus y, x plus y, or is x plus y, x minus y. Compare this with the difference of two squares you get here. Then you get x square minus y square. It comes to x square, x minus y, x plus y. Cos square a minus sin square a, cos square a plus sine square A plus 1. Could you get me? X square minus y square is equal to x minus y, x plus y. Cos square square minus sine square square is equal to the difference, x minus y, cos square minus sine square, x plus y, cos square plus sine square. And then, when you see this, you can remember any angle, cos square plus sine square is 1. Then you get cos square A minus sine square A plus 1. Then I would take this cos square A. Look at this. Is there any formula we know? If we spoke from the angle A, cos square A, 1 minus sine square A, sine square A, 1 minus cos square A. 1 minus sine square is cos square. Therefore, I'd write this to be 1 minus sine square A. 1 minus sine square A. 1 minus sine square is cos square A. When you get closer to the subject, when you get more familiar with the subject, you can do this mentally up to some extent. Cos square A plus cos square A comes to 2 cos square A. 2 cos square A is the right hand side. 2 cos square A is the right hand side. This is the first question I handled for today. And the second question, I will consider now would be the second question I will consider now is again a trigonometric identity. You got to prove sin A plus cos A 1 minus sin A cos A is equal to sin to power 3A plus cos to power 3A. Sin A plus cos A, 1 minus sin A cos A, you got to show is equal to sin to power 3A plus cos to power 3A. Look here. This is the right hand side, where the hand where you eat. Right hand side. This is the hand where you do not eat. Left hand side. Now, in a question, we can either start from left hand side and go to right hand side, or else you can start from right hand side and to go to left hand side. Now, when you see this, you can remember the O-level mathematics, the total of 2 cubes. A3 plus B3, what are the factors? A3, you take A here. Sometimes you might have done for O-levels. Sometimes your teacher may have not done for O-levels. What way did you get this knowledge? A3 plus B3, the factorization comes to. You call the factors of total of 2 cubes. A3, you put A plus, you put plus. B3, you take B. And the second factor written looking at the first factor, A square, multiply and change the sign and B square. Keeping this knowledge in your mind, you start from right hand side. It comes to sine to power 3a plus cos to power 3a. When you mean to say sine to power 3a, it means sine a complete thing to power 3, cos a complete thing to power 3, but still we don't go to that level to write it here. Then putting it into factors, when is A3 plus B3, the first factor, A3A, sine 3A, sine to power 3A, sine A. When is plus here. When is plus here. Cos to power 3A, you get cos A. You get cos A. Sine to power 3a, sine to power 3a plus cos to power 3a, the first factor a3a, b3b, and the second factor written observing the first factor. You square the first value, sine a square, sine square a. Multiply and change the sign, minus sin A cos A, minus sin A cos A. Then the second value is squared, cos A squared. Then square the first value, multiply and change the sign, square the second value. Sin 3a, you took sin A, the third cube. Cos 3a, you took cos A, plus you took plus. You'll write the second factor observing the first factor. Square this, multiply, change the sign, square the second value. This is to be taught in O levels, or is a gap between O levels and A levels knowledge. You got to know it. You can't say you don't know it. You got to know. Now you got to know. Then it would be sin A plus cos A. It would be sin A plus cos A. Take this cos square A here. And then you write this sin square A. Why I took them together? You know that cos square A plus sin square is equal to 1. Then I write this sin A cos A. Then I write sin A plus cos A. Sin A plus cos A. This 1 minus sin A cos A. That is the left hand side. That is the left hand side. Is you can start from the left hand side and simplify to the right hand side. Is you can start from the left hand side. All questions, you can't do it both ways. But there are some questions like this. You can start from right hand side and go to the left hand side. Or else you can start from the left hand side and go to the right hand side. If I start from the left hand side, sin A plus cos A, then this one, a little before, instead of cos square A plus sine square A, you wrote 1. Now, instead of 1, you can write cos square A plus sine square A. Cos square A plus sine square A. At that situation, instead of cos square plus sine square, you wrote 1. And this situation, instead of 1, you write cos square A plus sine square A. Then you get minus sine A cos A. Somehow that we got to show is equal to this side. Then, from sine A, multiply the complete expression. Sine A into cos square A. Sine A into cos square A plus. Then this into this would give you sine to power 3A. This into this would give minus sine A into sine A sine square A. You will get cos A. Now, from sine A you multiplied this, you got sine A cos square A. From sine A you multiplied this, you got sine to power 3A. Then you got sine A into this, sine square A cos A. Then, from cos A you try to multiply the complete expression. Plus, cos A into cos square A, you get cos 3A. Then cos A into sine square A, cos A, sine square A. Then cos A into this would be minus sine A. Cos A into cos A would be cos square A. Then observing this, you got a sine A cos square A here. It would get cut with this minus sine A cos square A. You got a minus sine square A cos A. It would get plus, it would get cut with this plus sine square A cos A. Even though you say sine square cos or is cos sine square. 3 into 4 is equal to 4 into 3. Equal, this minus, this plus, it gets cut. In the value you need is remaining, that is sine to power 3A, sine to power 3A plus cos to power 3A, that is the right hand side. Some questions, it's easier when you start from the right hand side and when you start on the left hand side and go to the right hand side. Some questions, it will easier when you start from the right hand side then to left hand side. Some questions, both methods will be equally like. Now, in this session, I tried to give you some simple idea about the basics of trigonometry. And I'll stop the class now and I'll say goodbye. Take care.